All right, welcome back for triangles. Okay, so let's start with our warm-up. I want us to start thinking about triangles and what angles we can figure out. So our warm-up says if the measure of angle A is 120 degrees, let's go ahead and just fill that in. So this is 120 degrees. What is the measure of angle B? Well, if this is 120, we know that A and B combined must be 180. So this angle of B must be 60 degrees, okay? Because adding those two angles together needs to give us 180 degrees, okay? And that's because A and B are supplementary, okay? If the measure of angle D is 40 degrees, so this is 40 degrees, what is the measure of angle E? Well, it's the same logic, right? So if D is 40, then E must be 140, okay? Because they have to add up to give us 180 degrees, okay? If the sum of B, C, and D is 180, what is the measure of angle C? Well, B and D add up to 100, so C must be 80 degrees, okay? Now, this is a very important warm-up because this is what we will be using in this lesson, okay? Some of these tricks. Winter break. This is chapter 5, section 1, angles of All right, so let's go ahead and get started. All right, so a triangle. A triangle is a figure formed by three segments joining three non-collinear points. The point where the segments meet, for example, A, C, and B are called our vertex or vertices, and the segments are the sides. So we've got triangle ABC, its vertices are A, B, and C. Its sides are AB, this side, BC, and CA. And then its angles are angle A, angle B, and angle C, okay? All right, so some classifications based on the sides, okay? We classify triangles in two ways. First is by the sides, and then we also classify them by their angle measures. So when we're talking about their sides, there's three possibilities. They can be scalene, which means that no sides are the same length, okay? They can be isosceles, where at least two sides are the same. And then they can also be equilateral, where all sides are equal. So we've got a scalene triangle with no congruent sides. We've got an isosceles triangle with at least two congruent sides. And then we've got an equilateral triangle, which are three congruent sides. Now keep in mind, this says at least two congruent sides. So all equilateral triangles are also isosceles, okay? Because if it's at least, if there were three sides that are the same, then it's also isosceles, okay? All right, classification by angles. So we've got acute, which means that all angles are less than 90 degrees. Obtuse, where one angle is greater than 90 degrees. A right triangle, where one angle is 90 degrees. And then equilateral, where all angles are equal, okay? So an acute triangle has three acute angles. So all three of the angles are less than 90 degrees, okay? And then we've got a right triangle where one of the angles is a right angle and then the other two are acute. One obtuse where we have, this would be our obtuse angle, right? One angle that's greater than 90 degrees and the other two are acute. That would be an obtuse triangle. Now, keep in mind, you cannot have two obtuse angles in one triangle, okay? Only one angle can be obtuse. If you had two obtuse angles, like let's say this was one of your angles and this was another, there's no way that this could be a triangle. This figure could be a triangle because once you have two obtuse angles, you can't connect these 2 points no matter what, okay? So just keep that in mind. So when you're identifying an obtuse triangle, only one of the angles can be obtuse. And then there's an equiangular triangle. So we had equilateral, now we have equiangular. That's where all three are congruent angles. And the only measure for these angles is 60 degrees, okay? Because 180 divided by 3, if all three of those angles are going to be the same, is 60, okay? So those have to be 60 degrees. There's only one possible equiangular triangle. It can be different sizes, right? But it has to be 60 degrees. I mean, the side lengths can be different sizes, right? But the angle must be 60 degrees. Okay, triangle sum theorem. So the sum of the measures of the interior angles of a triangle is 180 degrees. So the measure of angle A, which is this one, plus the measure of angle B, which is this one, plus the measure of angle C, is going to equal 180 degrees, okay? Always, always, always. All of the angles inside of a triangle, no matter what the shape is, will equal 180 degrees. Okay, so the exterior angle theorem. The measure of an exterior angle of a triangle equals the sum of the measures of the two remote, non-adjacent interior angles. So what this says is, let's take angle C, right? Angle 1 is the supplementary angle to angle C, right? So the measure of angle A and the measure of angle B added together must equal the measure of angle 1. Now, the reason this is the case, if we think about it, is adding the measure of angle A, B, and C, right? Measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. Do you agree? Because all of the angles inside of a triangle added together will give us 180 degrees. We also know that the measure of angle C plus the measure of angle 1 is going to give us 180 degrees, right? So all we do is we say we're going to substitute, right? We're going to take this 180 and we're going to substitute them in for each other. So we've got the measure of angle A plus the measure of angle B plus the measure of angle C. This left side is now going to be equal to this left side. The measure of angle C, angle C plus the measure of angle 1. So if we subtracted the measure of angle C from both sides, we would get the measure of angle A plus the measure of angle B equals the measure of angle 1. This is where this formula comes from, okay? Now that we've proven it, you guys can just use it, okay? You guys can use it in the future. All right, corollary. A corollary to a theorem is a statement that can be proved easily using the theorem. So the corollary to the triangle sum theorem is the acute angles of a right triangle are supplementary. So remember how all of the angles inside of a triangle equal 180? Well, if one of those angles, for example, C is 90 degrees, then A and B must add up to 90 degrees, okay? Because if you take 180 and you subtract 90 from it, you're gonna get 90 degrees. So your two angles that are left, which are A and B, must add up to be 90 degrees. Okay, state whether the triangle with two angles having the given measures is acute, right, or obtuse. So remember, we're only given two of the angles, but we can figure out what the third one is. So we have 55 and 43. So we're going to take 180, which will be the measure of all three of them, and we're going to take away 55, and we're going to take away 43. When we do that, what we're going to get is 82, and that is also an acute angle, so this would be an acute triangle. So an acute triangle for A. For B, we've got 47, 43, and now we have to figure out what that third angle is going to be. So if we took 180 minus 47 minus 43, that will give us 180 minus 47 minus 43. That will give us 90 degrees. So our last angle is 90. In this case, this is going to be a right triangle. Because remember, if any of your angles are 90 degrees, then it's a right triangle. If we've got two, which are 80 and 75. Let's do 180 minus 80 minus 75. The remainder will be 180 minus 80 minus 75. So our last angle is going to be 25 degrees. All three of those angles are less than 90 degrees, therefore it's acute. 33, 33, 180 minus 33 minus 33. This will give us 114. Yeah, 114. Now this angle is obtuse, so it's an obtuse triangle. And then lastly, we've got 24 and 66. So let's take 180 minus 24 minus 66, and we get 90. So 180 minus 24 minus 66 equals 90 degrees. So therefore, it's a right triangle, okay? So if you're ever given two of the angles, you can figure out the third one of a triangle just based on taking 180 minus the first two that you're given. Okay, so now we're going to use some of our the theorems that we've learned, and we're going to figure out the measures of angle A in each of these. So for the first one, for A, we've got a triangle with two angles, which are one which is 80, one which is 50. So this angle right here is going to be 180 minus 80 minus 50. So that's going to be 50 as well. So this angle is 50. This angle, since it's vertical to this angle, is going to be 50 as well. And 50 plus 50 will give us 100. If we take that away from 180, we know that the measure of angle A must be 80 degrees. Okay? B. So we've got 40. And we know that this angle is equivalent to this angle, right? So we're going to use this triangle down here as a template for figuring out what this angle needs to be. So the angle in this one is 60 plus 40, which is 100. So this one has to be 80 degrees. So this angle must be 80 degrees. So angle A must be 60 degrees. They're the exact same, they have the exact same angles, okay? All right. Now this next one, same logic, right? So we've got 30, we've got 110. Together they make 140. So this missing angle must be 40 degrees because all together they must add up to 180. So it's saying that this angle has to be 40 as well. If this angle is 30, then this angle must be 110 degrees. Okay? Now there's some extra examples in your homework that involve X and Y. We're not going to do any of those. I want to see how well you guys do on your own. Okay? All right, so example 2 continued. Find the measure of angle A given this angle is 120, this angle is 80, and we're trying to find this missing angle A. So if we know that this one is 180, we're going to go ahead and figure out this angle. This angle has to be 60 degrees. The reason is because these two added together, they're supplementary, so they must equal 180 degrees, okay? They're linear. So, and then in order to find A, we just take 180 minus 80, which is 100, minus 60, which will give us 40 degrees, okay? So A must be 40 degrees. All right, so E, F, G. Remember, E is this angle, F is this one, and then G is this one. If the measure of angle G is 100 degrees, and the measure of angle F, E, H is 3 times the measure of angle F. Interesting. And then it wants us to find the measure of angle F. Well, first off, we need to start with an equation, right? So we've got 180 must be equal to, let's add up all of these angles. So the measure of angle F plus the measure of angle G plus the measure of angle E, okay? So in this case, we know what the measure of angle G is. So we've got 180 equals the measure of angle F. We don't know what that is. We know that the measure of angle G is 100 degrees. And now, do we know anything about the measure of angle E? Yes, we do. We know that the measure of angle E must be 180 minus 3 times the measure of angle F. Why? Because this whole line is 180 degrees. And if we take away the angle up to this point, which is 3 times the measure of angle F, we will get the measure of angle E. Let's go ahead and solve this. Now we've got one equation, right, with one variable, which is the measure of angle F. So if we're going to solve this, it'll be 180 equals 100, let's add up the numerical portions, which are 100 and 180. This will give us 280 minus the measure of angle F, which is just 1 times the measure of angle F, minus 3 times the measure of angle F will give us minus 2 times the measure of angle F. We can subtract 280 from both sides, and we're going to get negative 100 equals negative 2 times the measure of angle F. We divide by negative 2, divide by negative 2. We are going to get 50 equals the measure of angle F. Okay, now this last one was a good one. Okay, it was a good one because it forced us to use our knowledge of the triangles and the angles outside the triangles to figure out that missing angle. Now, some of these can get a little complicated in terms of, okay, how do I even go about figuring this out? When you guys are doing these problems, always write down an equation that you can write, right? So initially I saw a triangle. So automatically I'm gonna write 180 equals all of the angles of that triangle added together. So F plus G plus E, okay? And then I use the other information that these two angles must add up to 180 degrees. Use what you've got, just start writing down equations and see if you can't figure it out on your own, okay? Here's your homework. I want you guys to work on those problems. For homework, you've got 3 through 6 all, and then 11 through 21. Let me know if you have any questions, and good luck.